saying today's goal, what we're going to achieve today in class, is you're going to get the ability to multiply rational expressions. And you might recall that rational expressions are big fractions that have lots of letters and numbers in them. Basically, you have a polynomial on the top and a polynomial on the bottom. With that, oops, no, that can go away. Here are the answers to your warm-up. And I mentioned, you know, as I was checking homework and I was talking to you about how you could get this warm-up started. One way to do it is just to multiply straight across. That's definitely a viable way to multiply fractions. However, you know, let's say I got super mean and I was like, no calculators on your next test. Not allowed to have them. I've seen enough. You know? You'd look at a problem like number 3 and be like, what? So, instead of multiplying straight across, and I'm going to make you focus your eyes right now on number 3, instead of multiplying straight across, we have this cool little shortcut, and I call it cross-canceling. What that means is that you can cancel or reduce out common factors that occur diagonally across your product. So for instance, do you see how I've highlighted 144 and 24? They have a common factor. 24 and 144 are both divisible by 24. 24 goes into 24 one time, so that's why I put that 1 there. Excuse me. And then 24 goes into 144 6 times. So I cross it out and I put a 6. Doing the other diagonal, working across the other diagonal, I look at 26 and 169 and I'm like, oh, those are both divisible by 13. 13 goes into 26 twice. 13 goes into 169 13 times. So I crossed out those common factors, kind of wrote what was left up, I wrote what was left over, sorry. So 6 times 2 is 12. 13 times 1 gives me 13. I did that whole problem without touching a calculator. So that's a little workaround for you there. Why I'm so big on cross-canceling is not because I want you to take a shortcut, you know. Ultimately, this is the technique we're going to use today. So I went ahead with the rest of the warm-up and I used this technique. For instance, in number 4, I cross-canceled the 2's. And then I multiplied across, so I have x over 3. In number 5, I cross-canceled the x's. And then what I had left was 1 over x squared. Are you guys okay with cross-canceling, you think? You're going to need it for today. Okay. So, let's talk about today. Today, again, you are multiplying rational expressions together. So, in general, you folks are very good at understanding that to multiply fractions, like a over b times c over d, you can multiply straight across. You don't need a common denominator. So this could be a times c over b times d. It sounds like you have a good understanding of that. Keep in mind this is only going to be possible if b and d are not equal to 0. So in the end, yeah, you can multiply straight across. But we're going to cross-cancel common factors first. Make that multiplication easier at the very end. I teach this process in 3 steps. They're not typed out for you. You're going to write them down just one time. So step 1. You want to factor the entire problem completely. So that's what we're going to do. I have to factor right now x squared minus 2x plus 1. That involves me thinking about the factors of 1 that make negative 2. Factors of positive 1 that make negative 2. You're looking at x minus 1 times x minus 1. On the bottom, we have x cubed plus x. You want to take the x out? It's a GCF. What's left over? X squared plus 1. By the way, remember, you don't write it if you don't understand it. So if you don't understand how I factored something, if you don't understand the technique that I'm talking about, you got to flag me down, all right? We did a warm-up 2 days ago. It was really extensive, and it was all about factoring. So I reviewed all of our techniques with you. If you're still having a tough time, you need to flag me down now, okay? So as we're going through it, you run into one, you're like, I wouldn't be able to factor that. Just tell me to slow down, and I'll take a minute and we'll explain that. So again, make sure you're following that rule. If you don't understand what I'm writing on the smartboard, you should not be writing it. All right, next. We have 4x squared plus 4. Greatest common factor is what I see there. They both have 4 in them. And then what's left over is x squared plus 1. And then in the second denominator there, I would think of the factors of -2 that would add to positive 1. That's going to be x plus 2 and x minus 1. Okay. In step 2, we basically want to cancel out factors of 1. Is how I say it. Things that would divide out eventually to make 1, we want to reduce out of the problem ahead of time. This is cross-canceling and canceling vertically. So cancel out factors of 1. Like I said, you could do it in 2 directions. You can cancel, like in the warm-up, top to bottom. That's vertically. Or you can cancel diagonally across your multiplication symbol. So, for instance, cancel the first numerator with the second denominator, and then the second numerator with the first denominator. You can do that. So now I'm going to go back and look at what I wrote in blue. And I'm going to first identify things that I could cancel vertically, top to bottom. And as I look at this first fraction here, I'm like, oh, yeah, I don't see any matches that appear in the numerator and denominator of that fraction. I'll look at the second fraction. I have 4 times x squared plus 1 over x plus 2x minus 1. I don't see anything in the numerator that repeats in the denominator, so there's nothing that reduces out there. Now I look diagonally, kind of across my multiplication symbol. I'm comparing my first numerator right now with the second denominator, and what I see is that there's an x minus 1 here and an x minus 1 here. So I could actually reduce those out. Because eventually they would be over each other in multiplication, making a factor of 1. That's why that kind of plays out. That's all that reduces out in that diagonal. In the second diagonal, I'm comparing the second numerator with the first denominator. And as I look at it, I'm like, oh, there's an x squared plus 1 here and an x squared plus 1 here. So I can cancel those out as well. Again, eventually they would be over each other when I multiplied, so we might as well reduce them out now. And that's basically step 2. You just kind of cancel out your factors of 1. Remember that these little slashes do turn into 1s. You don't have to write the 1s there. What they don't turn into is 0s. Then my whole problem would just be 0. So you kind of want to keep that in mind. Last step. We multiply and reduce again if possible. Like let's say you forgot to cancel a factor, it'll appear again. Just make sure your answers are always in lowest terms. So we multiply and we reduce if possible. Reducing was the skill that you practiced last night, like in problems 28 and 26. When we multiply fractions, once again, we multiply straight across. What I see left over on the top is x minus 1 and 4. And when we multiply straight across, you get 4 times x minus 1. On the bottom, I see we have an x and an x plus 2. If I take x times 1 times x plus 2 times 1, I'm essentially just taking x times x plus 2. So x times x plus 2 is the product that appears on the bottom. And I can't reduce anything. I can't cancel the x's in the middle because they're touching pluses and minuses. Can't cancel terms. So that's done. That's our answer. It's our 3-step approach. No. Leave it in factored form. You can if you want, but it's very common to just leave our answers in factored form. It's not like it's strictly forbidden. It's just common that we leave them in factored form. Any other questions? Good questions, my people. Well done. All right. Ooh, part B. So I'm going to follow that same 3-step algorithm throughout the process of this problem as well. So step 1, we got to factor everything. When I see weird exponents like 4 and 3, I think GCF right away. So in the first numerator there, I'll pull out a 5g to the third. And then what's left over is g plus 9. On the bottom, I see they have a common factor of g. What's left over there is g plus 9. That second numerator doesn't really factor. It has factors, -4 and g, but you don't need to write that any differently. And the second denominator, I look at that and I'm like, oh, -16 and 24 are both divisible by 8. I don't like when my leading coefficient like that is negative. So I'm going to go ahead and pull out a -8 and a g. And then what's left over in my parentheses, I have 2g, because that'll get me back to -16g squared. And then -8 times -3 will get me back to that 24. -8g times -3 gets me back to plus 24g. So that was me factoring everything in the problem. Now what I'm going to go ahead and do is start to cancel. I always cancel top to bottom first, and then I do diagonal. So for instance, I see I have a g plus 9 up here and a g plus 9 down there. So I'll reduce those out. And then I see I have g and g to the third. Those are factors because it's just touching some multiplication. I can reduce out this g so that this g to the third becomes g squared. Factor out that, reduce out that factor of g. Top to bottom in the second ratio, they're both negative. And I can cancel my g's. And then 4 over 8 actually reduces old school, you know. 4 goes into 4 one time, 4 goes into 8 twice. Now I'll try to cancel diagonally if I can. So as I look diagonally across the problem, I have 5g squared left in the first numerator. It's not going to cancel with 2g minus 3. So I go to the other diagonal, and I have like nothing left. So to finish that up, is that you guys? Wow. 5g squared over 2 times 2g minus 3. All right.